This is the start of Unit 8, and we're going to be talking about sequences. So let's write the word sequences here. Sequences. And 8.1 deals with understanding and using arithmetic sequences. So that's how we pronounce that word right there, arithmetic in this case. It's an adjective. So the warm-up here says, what does the italicized word mean in the context of these sentences? So it says, he could not get the lock undone until he put the numbers in the right sequence. Well, if you've worked with a combination lock before, you need to get the numbers in the right order. So let's write the word order right here. So when we're talking about getting things in the right sequence, we're talking about having them in the right order. And then it says she scored a goal in 4 consecutive games. Well, 4 consecutive games would be 4 games in a row. So in a row. So when we talk about consecutive, we're talking about things that come one after the other right in a row. Now, a sequence is a list of numbers. If we put it really simply, it's just a list of numbers. Any old list of numbers would do, but we're usually talking about ones that are produced by a formula and they come in a particular order. And this is kind of a more formal definition of what a sequence is. So a sequence is a function whose domain, so the things we plug in, is the set of consecutive integers. So integers that are right in a row, starting at the number 1. Unless we're told otherwise, the first thing that we're going to plug into this little formula or this little function is a 1. Now, each individual entry in the list is called a term. So we call them terms of a sequence. And each term has a counter, and that counter is called an index. And these are going to be really important because the index tells you it's the number that you plug into the formula to get the value of the term, and it keeps track of what term you're on. So here are some examples. Now we could say this one is a sub 1, and this would be b sub 9 and c sub 52. These are little subscripts. They're written smaller and down below, but we normally just say a1, and in this case a1 would represent the first term because we plugged in a 1. And then b9, that would represent the 9th term, and c sub 52, or just c52, would represent the 52nd term. And then a sub n, or an, that would represent the nth term. Now that sounds really weird, but that's what we call it. That's kind of a general term. We can talk about any one by saying it's the nth term. Okay, it's just kind of the general one. Okay, so let's come down here and let's take a look at some examples and see how this works. So on this example, it says list the first 4 terms given by, and in this case we've got a sub n, so this is what we call an nth term, or a general formula right here. And you'll notice that the index goes in both cases because it keeps track of which term we're on, and it's also the number that we plug into the little rule. Now what we're going to do is we're going to write this in what we call expanded form. So let's write the word expanded right here. And we're going to figure out what A1 is, what A2 is, what A3 is, and what A4 is. So in order to figure out what A1 is, we literally just plug in a 1 right here. So this would be A sub 1 is equal to, so we put a 1 right here and we put a 1 right here. So this would be 2 times 1 plus 5. So this is 2 plus 5, so this is going to be a 7. So then we're going to plug in a 2. So we put a 2 right here and here. So this is going to be 2 times 2 plus 5, that's going to be 4 plus 5, so that's going to be a 9. We're now going to plug a 3 into the formula, so this is going to be 2 times 3 plus 5, so that's 6 plus 5, that's going to be 11. And then you can kind of see what's going on here. You think the next one's going to be 13. Let's just double check and make sure that it is. So I'm going to go ahead and write that we would put a 4 right here and put a 4 right there, so this is going to be 2 times 4 plus 5. 2 times 4 is 8. 8 plus 5 is indeed 13, so we got that one right. So let's take a look at this next one. We're going to use the formula b sub n equals negative 3n plus 1. So here's what I'm going to write down. I'm going to write down b1, b2, b3, b4, and then I'm going to do some work down below, and then we're going to write the answer over here. So here's what we do on this one. We're going to put a 1 right there, and that means we're going to put a 1 right here. So b sub 1 would equal negative 3 times 1 plus 1. So that's going to be a negative 3 plus 1. So that's going to be a negative 2 for the answer there. So I'm going to put a negative 2 over here, and then I'm going to put a comma. And now we're going to figure out what b2 is. So the index is 2, so I put a 2 right here and a 2 right here. So b sub 2 is equal to negative 3 times 2 plus 1. Negative 3 times 2 is negative 6 plus 1, so that's going to be negative 5. So I'm going to put a negative 5 right here. Put another comma, and then we're going to figure out this one. Now, instead of writing down the b sub 3 here, I'm just going to plug in a 3 here. So we get negative 3 times 3 plus 1. That's negative 9 plus 1, so that's going to be negative 8. So I'm going to put negative 8, negative 8 right here. Put a comma, and now we've got the last one. So this is going to be negative 3 times 4. We just plug the index right there, just like we have every single time. and then we add 1. Now, you might be able to guess what's happening here. We're going down by 3 every single time, so this is going to be negative 12 plus 1, so we get negative 11. Okay, now it said write out the first 4 terms, so we got the first 4 terms here, we've got the first 4 terms right there, and then let's do this one right here. Now you'll notice this one is written slightly different, but we can go ahead and deal with that one. So we're going to do C1, C2, C3, C4, and then we'll write the answers over here. So I'm going to plug in a 1, so this is going to be 15 minus 5 times 1, so that's going to be 15 minus 5, that's going to be a 10, so I'm just going to write a 10 over here, speed up the work just a little bit. This is going to be 15 minus 5 times, again we're plugging in that index there, so times 2, so this is going to be 15 minus 10, so that's going to be 5. And then we're going to do 15 minus 5 times, plug in the index of 3, because that's what the formula said to do. And we end up with 15 minus 15, so this one's a 0. And then again, can you make a prediction of what's going on here? You might guess what that next one is, but let's check and see. 15 minus 5 times, plug in the index of 4, so this is 15 minus 20, we end up with negative 5. So there are the first 4 terms of each one of those. So I'll go ahead and circle that, and then we're all set there. Now, the cool thing about this is you can get any term you want by plugging in the index. All we need to do is plug in the index. So if you want the 51st term, you plug in a 51. If you want the 97th term, you plug in a 97. So again, those formulas go by several names. We've mentioned a few of these. So we call it a general formula. We also call it an explicit formula, and like we mentioned before, we call it an nth term formula. So we'll use these 3 phrases or these 3 vocabulary words kind of interchangeably here. Now there's another type of formula that can be useful even if it's not as convenient as an nth term formula, and it's called a recursive formula. So write the word recursive formula. And what a recursive formula does is it uses previous terms to define the terms that follow it. And because of this, a recursive formula always has to give you a couple of things. So the first thing is it's got to give you a starting place. In other words, it's got to give you a first term. It's got to give you some place to start. And then it's got to give you a formula to get from one term that you know to the next term in the sequence. So what we're going to do on this one is we're going to do the same thing we did up above, except for this is what a recursive formula or a recursion formula, you'll hear it referred to both ways. A recursion formula looks this way, and it's a little bit uglier. So we've got this first term right here. So a sub 1, the a1 is just a 7. So I'm going to put a 7 off to the side right here. So we've got that one. And then here's the recursion formula. And notice where the index occurs in this formula. So the index, the term that we want, would go right here, just like we did before. Like if we want the second term, we're going to put it right here. So if I want a sub 2, then I put a 2 right here, and then I've got to have a 2 plus, and then I've got a sub n minus 1. Well, if I put a 2 right here for n, then I need to put a 2 right here for the other n. So this is going to be 2 plus, and then I have a sub 2 minus 1. Now take a look at what happens here. This is a sub 2, this is 2 plus, this is a 2 minus 1. It's like we're doing a little bit of arithmetic down here in the index to figure out which term we're on. So this is 2 minus 1, this would be 1, so this would be a 1 right here. So what this is saying is the second term is 2 plus the first term. So this would be 2 plus 7, so we end up with a 9. So I'm going to put a 9 right here. Now, when you look at this, one way to think of the index, you can think of it, well, it's the term that you're on, or it's the term right before the one you're on. So this is the next term, and this is the one before it. So if we were on the nth term, this is the n minus 1 term, that would be the one before it. If that was a plus 1, then it would be the one after it. And there are formulas that work like that. So we've got this one here, we've got this one here. Now let's find the third term. So if you want to find a sub 3, here's what you've got to do. The formula says if you put a 3 right here, we write down the equals, we write down the 2, we put the plus, and then we do the a, and then we put a 3 here and a 3 here. So this is going to be 3 minus 1. So this means that a sub 3, the third term, is 2 plus, let's see, 3 minus 1, that would be 2, a sub 2. So that means we're going to take 2 and we're going to add it to the second term. So that's going to be 2 plus, the second term was 9, so we end up with 11. So the next one is 11. Now you can guess that the next one's going to be 13, but let's just check and make sure that it's 13. So this is going to be a sub 4, and let's see if we can speed this up just a little bit. If this one's a 4, this one's going to be 1 less than that. So this is going to be 2 plus a sub 3. that means the third term. So we're going to have 2 plus the third term of 11, because remember the third term was 11, and we do indeed end up with a 13. Now, recursive formulas are a bit of a pain. Let's do one more here so we kind of get the hang of it. It says find the first 4 terms given by a sub 1 is equal to 10, and then a sub n equals a sub n minus 1. So notice it's in a slightly different order, and then minus 5. And it says for n greater than 1. Now, sometimes they include this right here. If not, it's just kind of understood that once we figure out what the first term is, this formula right here, this recursive formula or this recursive definition or the recursion formula, as we say, it only works if you plug in something bigger than 1. So that means you'd have to start by plugging in a 2. So we're going to do a sub 1 is equal to 10. So I'm going to come over here and put a 10. And then a sub 2 would be, let's see what we get here. That means if we put a 2 here, we put a 2 there. So if this is the second term, this is the one before it. So that's going to be the first term minus 5. So this is going to be 10 minus 5. So we end up with 5. So I'm going to put a 5 right here. So the next one, if I want to find the third term, so I'm putting a 3 in here and I'm putting a 3 in here. So if I want the third term, I need to take the second term. So this is a sub 2. Notice how this is 1 less than that one right there. And then we're going to subtract 5. So the second term is 5 minus 5. We end up with 0. So I'm going to put a 0 for the third term. And then hopefully you're seeing what the pattern is here. If we want the next term, we take the one before it. So this would be the third term, and we subtract 5 from it. So this is going to be 0 minus 5. So we end up with negative 5. Okay, so there are the first 4 terms that come from that recursive definition. Again, they gave us a starting point, a first term, and then they gave us a way to get from one term to the next term. Now, again, recursive formulas, they're a bit of a hassle because if we have to get all of the terms in order until we get to the one that we want. So we couldn't just skip to the fourth one or skip to the third one. We had to get the first one, the second one, the third one, and the fourth one, and then the fifth one, and so forth. So if you want the 50th term in a sequence, you have to get the other 49 terms first. You have to get A1 through A49 before you can get to the 50th one, because you need the 49th one to get to the 50th one. Okay, let's take a look at the other side.
Okay, have you noticed anything about all the sequences we've dealt with so far? The numbers are either getting bigger or smaller by the same amount each time. So we are adding the same number to get the next term in that sequence. Since the difference between every pair of terms is the same, we call this a common difference. And we call this type of sequence an arithmetic sequence. Okay, so now we're going to look at the formula that we are going to use for these. So let's take a look at this sequence. So we have 4, 7, 10, and 13. So first we're going to look at the difference between A1 and A2. Most of us can probably look at that and say, okay, to get from 4 to 7, they were adding 3, so our common difference is 3. If you are not so great at doing that, especially on some of the more difficult ones, to find the common difference, you can take any term and subtract the one before it to get it. So we could say, okay, the second term is 7, take minus the term before it, and we still get our common difference of 3. So the next one, what is the common difference between a sub 2, so the second term, and a sub 3, the third term? So 10 minus 7 is 3. And what is the difference between a sub 3 and a sub 4? 13 minus 10 is 3. Okay, so our common difference is 3. We are adding 3 each time. We can even check it. 4 plus 3 is 7, plus 3 is 10, plus 3 is 13. And so on. So we are going to put this pattern into the following mathematical formula. So we're going to first start with the general formula. So a sub n, this stands for the nth term. So we could find any term, but we say nth term is just the generic one. D stands for our common difference, which we just talked about how to find. And then a naught or a sub 0, this is our initial term. and we'll talk about how we find that. Okay, off to the side, here's some useful things for you to find the common difference. We talked about this one would be you take the second term and minus the first term. And then also to find a sub 0, you're going to take the first term and minus the difference, because we're going backwards. Okay, and then here is our recursive formula for the arithmetic sequence. So a, rather than a sub 1, it will sometimes be written as a, saying this is our first term. Okay, and so here's our formula for that. A sub n equals a sub n minus 1 plus the difference. And a sub n minus 1 is talking about the previous term, and then we're going to add the difference, and that will give us the next term. Okay. Okay, so now we are going to find the general and recursive formula for each arithmetic sequence. So I'm going to find the general formula first. So we are going to find a sub 0. In order to do this formula over here, this is the one I'm going to do because this is the general formula. Okay, I need to find a sub 0 first. So it tells me right here, okay, if I want to find the initial term, it's like I'm going backwards. I'm finding the term before the first term, so I'm going to minus the difference. If this is my first term, I need to go backwards. So we're going to minus negative 11, which is 10 plus 11. So that's 21. Okay, so now that I found a sub 0, now I can go ahead and use my formula. So we say a sub n equals our difference is negative 11, and we multiply it by n plus our a sub 0 that we found. So this would be plus 21. And that would be my general formula. Okay, the recursive formula is pretty easy to write out. Okay, and we have it up here, so a sub n equals a sub n minus 1 plus our difference, plus 21. So all the recursive formula is saying is we are going to take, to get whatever term we need, we're going to take the term before it, and we're going to add 21, and that will give us our term. So this is our recursive form. Okay, so now we're going to do this next example. So they use the variable b instead of a, but it works the same way. So we need to find our general formula. So first we need to find b naught. In order to find that, I take the first term, which this one they did not have the subscript of 1, but if it's not written, it's assumed that it is b sub 1. So 2 minus the difference, and we get negative 3. Okay, now we can write our general formula. So we say a sub n equals our difference, which is 5, 5n, 5 times n, plus negative 3. So I can just write minus 3. Okay, now we're going to write our recursive. So our first term is 2. And then we're going to say b sub n equals b sub n minus 1. Make sure that is in subscript right there. And then our difference is 5. So we just say plus 5. It's saying, okay, we're going to take the term before it. To get whatever term we want, we take the term before it, and we just add 5. Okay, so now we're going to find a general and recursive formula for each sequence, but this time they did not give us a sub 1 and d. We have to figure those out. So first let's figure out what a sub 1 is just always going to be our first term. So in this case, it's 4. The first term is 4. And then our difference, once again, most of us can probably look at this and figure out the difference, but remember, if you're ever struggling, take the second term, 7, and minus the first term. 7 minus 4 is 3, which makes sense in our sequence. 4 plus 3 is 7, plus 3 is 10, plus 3 is 13. Okay, so now we have those same bits of information that they gave us up there. We just had to get it from the sequence that was given to us. So now we're going to do the same thing. So first we have to find a sub 0. And remember, we're going back to the initial term. So instead of adding 3, we're going to subtract 3. So we take the first term and we minus the difference, which is just 1. And now we can write our general formula. So our difference is 3. That's what we're adding each time. And our initial term is 1. Okay, what's nice with the general formula is we can get any term. We could get the 100th term, the 50th term, and we can just plug it into this formula to figure that out, and it's a lot more useful to us. Okay, now let's go ahead and do the recursive. A sub n minus 1 plus 3. This means if I want to figure out the 50th term, this one would be a bigger pain because I would have to figure out all 49 terms before it. I'd have to know the 49th term in order to get the 50th term because I need to take the term before it and add 3. Okay, now the next one, let's look at this one. So our first term is 55. And the difference on this one, so 49 minus 55 is negative 6. I could also check it. They are subtracting 6 each time. 55 minus 6 is 49, minus 6 is 43. Okay, that looks right. Okay, now I need to find the initial term, a sub 0. So I'm going to take 55 and minus negative 6, so that will become plus 6. To get 61. And now we can put it in our formula. A sub n equals, okay, our difference is negative 6. That's what we are adding each time. Negative 6n, and our initial term is 61 plus 61. Okay, and our recursive one, a sub n minus 1, we take the term before it, and we subtract 6. We put our difference there. Subtract 6. Okay, so now this one's a little bit different. They tell us the term, and we need to figure out what that is. So anytime they're telling us what term is, we're going to want to use the general formula. The recursive formula is not going to be very useful to us, so we want to make sure we use the general formula. So we're using this formula above. So let me just write this right here so we know which formula we're using. Okay, and we want to figure out the 102nd term. So we're going to say a sub 102 equals 3. And since they plugged in 102 for this n, telling us what term it was, we're going to plug in 102 here. 102 plus 1. Okay, and then we can just figure that out. 3 times 102 is 306 plus 1 is 307. So the 102nd term in this sequence is 307. And you're not going to want to be using the recursive because you're not going to want to write out every single one, write out 102 numbers. That's going to take a very long time. Okay, B is the same, but this time they, instead of saying you putting it in the subscript, they just told you what you're going to plug in. So we're going to say a sub 35 because we're going to plug in 35 for our n. Okay, and this time we are using this formula above, the negative 6n. So we're going to say negative 6, and for n we're going to plug in 35 plus 61. Okay, negative 6 times 35 is negative 210 plus 61. And we get that the 35th term, negative 210 plus 61, is negative 149. Okay, the last type you might see, this one is telling us what the term is, and we're trying to figure out, okay, it's kind of telling us the answer, what that value is, but we need to figure out what term number it is. Is it the 20th term, the 100th term, that way. So we are going to plug it in, let's see, 5549, that's this formula up here that we're going to be using. So I'm just going to write it so you know what formula we're using. So they told us what it is going to be, so it's going to be 203 is the value of that term, and we're trying to figure out what is its place, the what term. So we're going to say negative 6n, so we don't know what term it is, so we don't know the n. Okay, so now we're just going to solve this. Minus 61. Negative 264 equals negative 6n. Divide by negative 6. And let's see, 264 divided by 6. 44. So negative 203 is the 44th term. Okay, go ahead and circle your self-assessment, how you're feeling about this. We're going to spend a couple more days on this, so if you're like, oh, that's kind of a lot to take in, and tomorrow we're going to be working on our assignment.